Today's lesson is 5.2, Operations with Rational Expressions. So we're going to talk about four of our operations, our four most basic operations: multiplication, division, addition, and subtraction. And actually in this case, multiplication and division are the easier of the two. So we're going to take a look first at, saving here a little bit. To multiply. We're going to talk about 3 steps to multiplying. First of all, you want to factor everything. So factor everything first. And then secondly, you want to multiply numerators and denominators. And third, you can simplify. And in fact, there will be some simplifying happening after we factor everything. We'll be able to do what's called cross-reduce. So you might kind of add that in there. We can cross-reduce sometimes before we even move on to multiplying. So we just did 5.1, which is all about simplifying rational expressions. So you can go back to that lesson if you're forgetting how that works. And then the other inverse operation of multiplication is division. So to divide, first factor, next we flip the second expression, and that's just like with basic division of fractions. Keep the first one the same, change to multiply, and flip. And so the third step is multiply. And refer back to here if you need extra guidance on that part. So let's take a look at a few examples. Example 1, part A. If we had 2/7 times 7n squared over 9. We're multiplying, so we're going to apply these steps. Factor everything. Everything is factored. Cross-reduce. So that's where we look at the diagonal and see if there's any common factors in here. You see the 7 is a common factor, so we can cancel that out. And now we multiply across. Remember when we cancel and that's the only thing that was in the numerator or denominator, we make it a 1. And now we multiply 2 times n squared, we get 2n squared over 1 times 9, which is 9. And that's our answer. Do example B over here to the side. If we have 1 over 10 n plus 80 times 10 n minus 30 over 4. How do we handle this one? Well, Number 1, factor everything first. So this is just like what we do when we're simplifying. So we're going to look at each different piece and see what we can do to factor. In this case, we have a 10 as the GCF. In the numerator here, we also have a 10 as the GCF. And now we can look to cancel things out. Notice a 10 and a 10. Let's see, anything else we can reduce? Nothing else. So now we just multiply. So we have 1 times n minus 3. 10 minus 3 over n plus 8 times 4. So we write that as 4 times n plus 8. Now we could talk about excluded values, but I'm going to leave that out for our purposes for this lesson. Our third example, b squared plus 8b minus 9 over 10b plus 10 times b plus 1 over b squared plus 4b minus 5. And now is when we begin factoring everything. So you can see we have a trinomial in our numerator. So we're going to look for two numbers that multiply to get -9 and add to get 8. I think of 9 and 1 with maybe a -1. -1 times 9, that adds to 8. I'm going to factor this into b minus 1, b plus 9. The denominator here, 10, is the GCF, leaving us with b plus 1. You can kind of start to see things already. Remember, we consider things, our numerators have an imaginary set of parentheses around them, as do our denominators. But our second trinomial here in this expression can also be factored, similar to the first one. We have -5 and 4. So two numbers multiply to get -5, add to get 4. Thinking of 5 and 1 again. So 5 times 1, with the 1 being negative, adds up to 4. Adds up to 4. So rewrite that as b plus 5, b minus 1. Cancel that out. It's kind of messy to look at, but if you can pay attention to what's on the top and what's on the bottom, we can look to reduce within a fraction or along the diagonals. So this is the fun part. Boom. Got a b plus 1 canceled. B minus 1 canceled. I think that's about it. And now we multiply. Numerator times numerator over denominator times denominator. So b plus 9 times, the only thing left here is 1, so just b plus 9 left in the numerator. A 10 and a b plus 5, so 10 b plus 5 in the denominator. And that's our final answer. Example 2, I'm just going to do one example of dividing, because it's just the same process with one extra step. So 9 over 5 minus v divided by v squared minus 3v minus 10 over 7v plus 14. All right, can't factor either the numerator or denominator here. Trinomial, so what two numbers multiply to get -10 and add to get -3. So is that 2 and 5? With the 5 being negative, so that adds to -3. So we can rewrite this expression as v plus 2, v minus 5. The denominator here, you see the 7 as the GCF, so we can write that as 7 quantity v plus 2. Cancel out that. And now we think about the flip the second expression. So we're going to rewrite this as 9 over 5 minus v times, now the numerator and denominator switch, so we have 7 quantity v plus 2 over v plus 2 v minus 5. So now we look to cross reduce. Well, let's see, what do we have here? We've got this v plus 2 and v plus 2. We talked about this earlier, so we could actually rewrite this 5 minus v. It's very similar. We're not going to cancel out, but we're going to be able to simplify this a little bit more if we rewrite this as -1 v minus 5. Factor out the -1 when they're really close. Now we can go ahead and multiply 9 times 7 is 63 over -1, and v minus 5 times v minus 5 is going to be v minus 5 squared. So that's how that works to be a little bit simpler. In fact, we can just write the negative in front of the fraction sign, another way to do that. So there's your one problem with practicing division of rational expressions. Our last topic is adding and subtracting rational expressions. We're just going to say rationals for short. So steps for this process: number 1, factor everything. Two, this is everyone's favorite. Find a common denominator. You'll see these are the same, it's the same or similar process as when we're just adding to fractions. Number 3, rewrite the numerators. Number 4, combine the numerators. And number 5, finally, simplify. We're going to do 2 examples here. Example, so this is example 3, and continuing our notes. Part A, we have 5x over x squared minus 9 plus 2 over x minus 3. So factor everything. That means we need to rewrite this x squared minus 9, difference of perfect squares, as x plus 3, x minus 3. I'm looking at these two denominators and I need to find the least common denominator. So look for any factors they have in common. They both have an x minus 3. So that's in there. But we also need to include at least the greater of the two denominators, so that we also need to include that x plus 3. And that's our, in this case, this first denominator is our least common denominator. So the only thing we'll have to adjust here is to multiply this second fraction, the numerator and denominator, by the part that's missing, the x plus 3. So that's going to look like, so step 3 now, rewrite the numerators. So we're going to rewrite 5x and 2. Now we're going to combine the denominators. I'm going to keep this as x plus 3 in its factored form, x minus 3. I'm going to rewrite this first denominator, x minus 3. So you can see everything's the same so far, essentially. But now I have to multiply the second fraction by the x plus 3 over x plus 3. So this simplifies to, so 5x over x plus 3, x minus 3, plus, we're going to distribute the 2, so that becomes 2x plus 6 over x plus 3, x minus 3. Got the common denominator now, and numerators are simplified, so now I add the numerators. 5x and 2x is 7x, and then we have the plus 6 over x plus 3, x minus 3. And that's my answer. We'll do one more. So in this example, we have 3 halves plus 3x minus 2 over 3x squared plus 9x. First thing we do, factor everything. The only thing we can factor is the second denominator here. We can factor out a 3x, leaving us with x plus 3. Now to find the least common denominator, there are no common factors between 2, 3x, and x plus 3, so I just have to multiply them all together to get my common denominator. And then we have to make up for what's missing in either of the two rational expressions. So in this first one, let's rewrite the original. So we're going to rewrite 3 halves. And the part of this denominator that's missing from our least common denominator is this whole thing. So I need to multiply numerator and denominator by 3x times x plus 3 times 3x x plus, oh, that's x plus 3. There we go. Extend this little fraction line here. And plus, kind of rewrite what we already have again, 3x minus 2 over 3x x plus 3. The part of our denominator that's missing on this one is just the 2. So I'm going to multiply 2 times numerator. And again, think about those parentheses, invisible parentheses. We'll throw those in there now, so we know that we're distributing that 2 to both parts. Now we can combine the numerators. So let's, what does this work out to be? 3 times 3x, we get 9x times x plus 3. So this is this numerator here. And I'm going to go ahead and distribute. So that's going to be a 9x squared plus 27x over 2 times 3x. Might as well multiply that together. 6x times x plus 3 plus 2 times 3x, that's 6x, minus 4 over 6x times x plus 3. And now we add things together. So 9x squared plus 27x plus 6x minus 4. 27x and 6x. Adding those two together, we get 33x. So 9x squared plus 33x minus 4 over 6x x plus 3. Now we could look to simplify this numerator here. By using our split the middle method, which turns into factor by grouping. And you can do that on a separate sheet of paper. What we wind up is with, this doesn't actually simplify any further, so we're just gonna finalize that answer there. So this is adding, and then subtracting would just be the same idea. Let's find a subtraction one on your homework assignment so we don't have to add more to our notes. Let's take a look at this question here. Number 16. You can see nothing to factor here. We could factor a 3 out here. Looks like 3, 6. We could actually simplify that to 1/2. And now we're looking at these two denominators for our least common denominator. These don't have any common factors, so we're going to multiply everything together. The 2 times the 3 times the a minus 1. And that's going to give me, so 5a plus 4 over, so 3a minus 1. I have to multiply numerator and denominator by 2. I don't need a parenthesis there, I'm just going to make that multiplication sign. And then minus 1/2. Has the 2, needs the 3 times the a minus 1, so we're going to multiply by 3a minus 1. Kind of rewrite this, so that's going to be 10a plus 8 over 6a minus 1 minus 3. Ugh. Let's just do 3. So let's distribute, since the 1 times 3 is just 3, let's do 3 times a. So 3a minus 3 over 6a minus 1. And the key with this subtracting is to recall that this minus sign distributes to both terms here. So that's 10a minus 3a, which is 7a. And then that's 8 minus negative 3, so it's a plus 3. It's going to be 11. 8 plus 11 over 6a minus 1. And that's our subtraction example.